For this lesson, our focus standard comes from Grade 8, Expressions and Equations, Standard 8, Analyze and Solve Pairs of Simultaneous Linear Equations. Our topic for this lesson comes from Systems of Equations, Writing and Solving a System of Equations for Word Problems. Our essential question is, how can we use a table to organize our equations and then follow the 3 steps to solve the system? Please take a moment, pausing the video if you need to copy the standard, topic, and essential question into your header, along with today's date, set up your question column and your note column, and resume the video when you're ready to begin. Here's a typical problem that you might be asked to use a guess and check table to solve. But this time we're going to set up a guess and check table and use that to write our equation. So here's the problem. The number of students attending the spring play was 150 fewer than 3 times the number of adults. Together, students and adults purchased 1,778 tickets. How many students attended the spring play? So think for a moment how you might set up a guess and check table and the different parts that you would need. It might look something like this, right? Where when you read the story problem, I encouraged you to at the beginning of the year, I'd encourage you to bullet out the important information. So maybe something like this, that there's a total of 1,778 tickets, that the number of student tickets was 150 less than 3 times the number of adult tickets. Well, that's a mouthful, but we know that there's a total, we know that there are student tickets, and we know that there are adult tickets. So we would probably make a column for each of those things. The number of student tickets, the number of adult tickets, the total number of tickets, and then of course our evaluation of our guess. So check if it was right, X if it wasn't, and we would continue on making as many rows as we needed to, guessing and then checking our work to see if we could come to the answer. So the whole reason that we teach you how to use guess and check tables is that it comes in real handy when you're learning to write equations. So instead of using these rows of our guess and check tables to fill in numbers and start guessing and walk you through that process, I'm going to show you how to use these rows to write an equation. So of course, as we learned in the last video, we need to start by having a let statement. So here I have my let statement. I'm going to let A equal the number of adult tickets and S equal the number of the student tickets. And so the most simple equation would to take my total here, 1,778, and to put it in this box here. And this is the number of student tickets, so I'm just going to go ahead and use my variable S. And here my variable A for adult tickets. And then all I need to do here in order to make this an equation is to plug in an equal sign and some kind of operation, and I then have an equation. So pause the video and think about where, using these 3 terms, would the equal sign go and the operation sign. Alright, let's see if we agree. So I'm going to take one of these. I've already prepared these. So I'm going to go ahead and put my equal sign here because that's the total number of tickets, right? So usually the equal sign goes before that. And I know that if I combine the number of student tickets to the number of adult tickets, that will give me my total, and the way that I combine things is by adding. So I'm going to put my addition sign here. So I've already written one equation. The number of student tickets, S, plus A equals 1,778. But that's still not enough. That's not, I have 2 variables here. I need some more information. So that's where this second bullet point comes in handy. I know that the number of student tickets was 150 less than 3 times the number of adult tickets. So the number of student tickets was is a past tense for equal. So I'm talking about student tickets. So I could put an equal sign here, put my variable s here. So I know that the number of my student tickets was 150 less than 3 times the number of adult tickets. Go ahead and pause the video again to see if you can write your expression, and then resume the video to compare your answer with mine. Again, I'm using this information here, that the number of student tickets was 150 less than 3 times the number of adult tickets. Well, I know that 3 times the number of adult tickets, I just say 3A, right? And from that, I'm going less than 150, means that I have to subtract 150. So the expression would probably look something like this. The number of student tickets equals 3 times the number of adult tickets minus 150. Now I have a system of equations. I've used my guess and check table and kind of the skills that I learned from doing that to write 2 equations. So the first part is done. How can we use guess and check tables to write a system of equations? But now we're going to need to go back and use our equal values method to solve this system of equations. So down below, I've given you a few steps. I consider there to be basically 3 steps when using the equal values method to solve a system of equations. First, you have to make sure that both equations are solved for the same variable. At this point, they aren't. We have one here where it's solved in terms of a variable s equals, much like y equals mx plus b. We could think about that as being linear. But this other one has both variables on the same side of the equal sign, set equal to some value. So I have a little bit of work to do there. Then, once I am able to solve them both for the same variable, I'm going to set the 2 equations equal to one another and solve for the variable. And then finally, I'm going to plug my solution back into one of the equations to find the value of the second variable. Might sound a little confusing from that description, so let's go ahead and take our work here and see how that would look. So let's start here with step 1. I already mentioned that I have one equation here set solved for s. So it would make sense that I would then take my other equation, s plus a equals 1,778, and solve for s. So that can be done pretty easily. Down here for step 1, I've already written that out, although I wrote it in a slightly different way. But that shouldn't really matter. So I have a plus s is equal to 1,778. So in order to solve for s, I'm going to have to subtract an a from both sides. If I do that, I end up with s is equal to 1,778 minus a. This would work the same if I would have kept the formatting the same. That was just a mistypo on my part. So now I have 2 equations. I turned this equation into this, and I still have s is equal to 3a minus 150. So step 1 is done, and I'm ready to set the 2 equations equal to one another. So you might remember us doing this when it would say something like y equals, and then y equals mx plus b form, and y equals. Well, this is the same thing, but they're both just solved for s, so I'm going to take this expression and set it equal to this expression. So let's go ahead and do that for step 2. So that's exactly what I just said. So I took this expression from the second equation and put it here, and I took this part of the expression from this equation and put it on the left side. Now, really it could have gone on either side as long as we're leaving the s out of it for right now. And we're just going to solve this equation for a. So feel free to pause the video now here and see if you can solve this equation for a and come up with a value that would make this the equation true. So I want to get all my variables to one side and my numbers to the next, so I decided to start by adding an a to both sides, which leaves me with 1,778 is equal to 4a minus 150. So now that all my variables are on the right side, I want to get all my numbers to the left side. So I'm going to do that by adding 150 to both sides. And when I do that, I end up with 1,928 is equal to 4a. And now I want to get a by itself, so I'm going to divide both sides by 4. And I come up with that a is equal to 482. So I actually now know that the number of adult tickets sold, this a here, is going to be 482. Now we just have to plug this solution in for step 3 back into one of the equations to find the second variable. And I'm going to go ahead and use this equation here because it's already set to s equals, and I'm looking to find the value of s. So I've just jotted that equation down here. S is equal to 3a minus 150. And now I'm going to plug in my solution from step 2 in for a, which is 482. And go ahead, feel free to work up ahead of me, pausing the video if you need to. I multiply that out, and 3 times 482 is 1,446. And so that minus 150 is going to be equal to the number of student tickets. And if I take 1,446 and I subtract 150, I end up with s is equal to 1,296. So now I have a solution to both. It's always a good idea to probably plug those back in to these two equations and make sure that when I have 1,296 for student tickets and I add that to 482 for the number of adult tickets, we want to make sure that that does in fact add up to 1,778 tickets. I've already gone ahead and checked that math. It does indeed add up, so we are set to go. The last thing is always just to write your answer in a sentence, so you might have something like this. If 1,778 tickets were sold in total and the number of student tickets was 150 less than 3 times the number of adult tickets sold, then the number of student tickets was 1,296 and the number of adult tickets sold was 482. Please make sure that your notes are completely filled out, that you've written any questions that you may have, and you come ready to practice this skill and discuss it more in class.